हम लोगों ने टाइमर इनेबल कर दिया, टाइमर इनेबल बिट हम लोगों ने यहाँ पे सेट कर दिया। हम लोगों को इनिशियल काउंटर वैल्यू सेट करनी है। सो जहाँ से जैसे हम लोगों ने टाइमर स्टार्ट किया, एक वैल्यू से वो स्टार्ट होगा, फिर उसके बाद वो ऑटो रिलोड रजिस्टर से फिर से वैल्यू लोड करेगा। तो उसको एक सिंपल अगर मुझे दिखाना हो तो व्हाट विल हैपन इज कि मेरा एक काउंट वैल्यू है, काउंट रजिस्टर है, इसको मैं x से इनिशलाइज करूँगा। मैं अप काउंटिंग कर रहा हूँ या फिर डाउन काउंटिंग कर रहा हूँ। अभी तो मैं डाउन अप काउंटिंग कर रहा हूँ। यहाँ पे अगर यहाँ पे जैसे हम लोगों ने देखा दैट 0 एज अ अप काउंटर, सो मैं यहाँ पे अप काउंटिंग कर रहा हूँ। तो ये वैल्यू जो है वो मेरा 16 बिट तक जाएगा। 16 बिट मतलब 65536 या फिर 32 बिट वैल्यू तक जाएगा। सो व्हाट विल हैपन इज once this reaches the maximum value, that is ff. Once this reaches maximum value and it counts up, so what will happen, it will again go to 0 0 0 0 0 0 0 0 and in between UEV update event will be generated. UG will see that flag, which flag will be set, but update event will be generated. But instead of loading this value 0 0, the auto reload register value, ARR value, that is, let's suppose we have declared as n, it will be loaded into this count register. Okay, so after transitioning from FFFF, instead of loading 0 0, it will load value n. So यहाँ से यहाँ पे transition आएगा. So our count register will have to initialize it to initial value before we enable our timer. Our timer is up counting that we have seen. It is 32 bit, so 2 raised to 32, that will be the maximum value it will reach. Now our counter will count till this point, till FFFF. Once it reaches to this point and it increments by 1, it will generate an update event. After generating an update event, it should go to 0 0 0 0 value. But instead of going to this 0 0 value, what will happen is our counter, once reaches to this value, it will generate update event. I'll write it as update event, and after generating an update event, it will load n value. N value, that is ARR value. It will load the ARR value into this count register. So our counting again starts from n. Let's take an example. We load 250 and our counter is going till 256. So 251, 252, it will count 253, 254, 255. So 255 is the maximum value. So instead of going to 256, whatever value is there, let's suppose in ARR register we have value as 120 decimal. So it won't go to 256. Instead it will generate an update event, and after generating update event, it will again load value 120 and will start counting from 120 to up, like 121, 122, 123, likewise. So what we'll have to do is we'll have to give the initial value of the count register. This is our count register. We'll calculate this value. For now, let's keep it as 0. So it will start counting from 0. Now we have to give the auto reload register value, ARR. That value we'll have to calculate. So अभी के लिए हम लोग काउंट रजिस्टर में 0 वैल्यू लोड करेंगे. ये वैल्यू हम लोग आगे जाके भी मॉडिफाई कर सकते हैं कि हम लोगों को एग्जैक्ट वैल्यू क्या देनी है. So we'll have to calculate this ARR register value according to the delay that we need. So prescaler up counting mode. Up counting is automatically selected. Internal clock is automatically selected. Now we'll load the prescaler, PSC. Now let's go into our register definition. So clock division is set to 0 0. Auto, like it is up counting, age aligned. Then we have update event enabled. Now let's come to this control register 2. Now let's see the description for control register 2. Control register 2 में कौन-कौन से bits है which are necessary. Like we are not interested in control register 2 because it is not specific to our simple application of delay generation. So we can skip this. Again, timer to slow mode, we can skip this. DMA interrupt enable, we can skip this, we are not using DMA interrupts, or we are not using any interrupts. Status register, this one is important. Now here you can see that UIF flag. UIF flag is of our interest. So when this flag is set to 1, it means update has occurred. So you can either process that interrupt, or you can process an event according to that interrupt or according to this flag. Now let's see the description of this flag. This flag is set by hardware on update event. Okay, it is cleared by software. Now no update occurred and update interrupt pending. This bit is set by hardware when registers are updated. Means when the value overflows or underflows, means the value overflows from FF or maximum value to 00 or auto reload, or it underflows from 00 to auto reload value. So at that time update event is generated. That we have seen in the description, in the diagram that we have seen in upward in the timer description. So here when CNT is reinitialized by software using UG bit or timer EGR bit, if URS is set. So this is the description basically. But see, apart from this, we are not interested in any of the rest of the bits. So UIF bit is 0, bit number 0. So what we will do is, we'll go over here, we'll say while timer2, now we have SR register, that is status register, ampersand 1U shifted by bit num 0. If it is false, if this is false, then our application will stay here. So rather than declaring this like bit number 0, what we can do is, we'll go into the timer.h file. Inside this, hash define timer x sr uif, right? This is bit number 0. So we'll use this over here. Okay, so this makes it simplistic. We can do this for CR1 also. So हम लोग ये क्यों कर रहे हैं, क्योंकि हम लोगों को पता है CR रजिस्टर या फिर SR रजिस्टर में जैसे हम लोगों ने UIF बिट को वैल्यू 0 दिया, बिकॉज इट इज ऑन बिट नंबर 0 एंड वी आर मॉनिटरिंग दैट बिट. तो वो इजीली रीड होने के लिए, कोड में इजीली रीड होने के लिए हम लोगों ने वो माइक्रो डिफाइन कर दिया है. अभी हम लोग काउंटर इनेबल CEN का भी बिट डिक्लेयर करेंगे. सो विल डिक्लेयर द CEN बिट सिमिलरली इन timer.h हैश डिफाइन timer x CEN. This is also bit number 0. Okay, this is in CR1 register, CR1 CEN. So we'll go into main, we'll copy this and we'll paste this. We'll copy this and we'll paste this over here. So this makes it simplistic. Now after this, what we can do is, we can toggle the LED. For toggling, we'll need to initialize the GPIO pin as an output and use it here. Now अभी LED टोगल करने के लिए देखो यहाँ पे क्या हो रहा है कि हम लोग वेट कर रहे हैं डिले जनरेशन का. डिले जनरेशन मतलब जब तक ये UIF बिट सेट नहीं होता तब तक हम लोग यहीं पे रहेंगे. वंस दिस बिट इज सेट, विल रीड दैट. वंस वी रीड दैट, विल हम लोग ये रीड होने के बाद फिर से LED को टोगल करेंगे. सी विल गो इनटू SR रजिस्टर. नाउ ये बिट क्लियर कैसे होता है ये भी हम लोग देखेंगे. इट इज क्लियर्ड बाय सॉफ्टवेयर व्हेन CNT इज रीइनिशियलाइज्ड. सो इट इज सिंपलिस्टिक, क्लियर्ड बाय सॉफ्टवेयर. सॉफ्टवेयर से हम लोग इसको रीसेट कर सकते हैं. सो व्हाट वी कैन डू इज, we'll come over here, timer2 SR, and we want to clear the bit number 0. So what we'll do is, we'll use this. We are not setting it, instead we are clearing it. So we are clearing the UIF bit. Now let's go to the next register, event generation bit. Now trigger generation, hit update generation, reinitialize the counter and generate an update event of the registers. So this bit can be set by software and automatically cleared by the hardware. Then compare capture, we are not interested in this register. CCMR2, again not interested. CCER, compare capture enable register. So we are not again interested into compare capture for this tutorial. Now the count value can be of 15 bits. The prescaler value can be of 15 bits. Sorry, 16 bits. And the auto reload value can be of 16 bits. Now counter value, its reset value is 00. Now let's assume that our internal clock to the timer peripheral is of 8 megahertz. So our clock is of 8 megahertz internal clock, right? And we want the timer delay of, let's say, 5 seconds. So what we will do is we will use a prescaler of 8. So 1 megahertz, sorry, 8 megahertz divided by 8 will give 1 megahertz to the timer. So this is prescaler value, PSC. Now if I divide it by 1000, so if I divide it by 1000, then it becomes 1k. So what we can do is we can use a prescaler value of 8000. So we will load a prescaler value of 8000. So we cannot directly load the 8000 value because our counting starts from 0. So we have to write 8000 minus 1. Now we will give a description that we are considering 8 megahertz internal clock divided by 8000 will give a prescaler clock of 1k, 1 kilohertz. So now prescaler, you can see that FCK prescaler value, we can load the value of 65536 plus 1. So plus 1, the count value is equals to the count value. Let's go over here. Value is equals to FCK, that is 8 megahertz divided by prescaler value, that means 8000 plus 1. So if we calculate this, we will have to load this value as 7999, or we will have to load this value as 7999 plus 1. It means we will get 1 kilohertz. So 799 will be our prescaler value. So that's the same thing that we have done over here. Now coming to the next register, that is auto reload register. The auto reload value, it is loaded into actual value. Now we know that 1 kilohertz means 1 kilohertz means if we take inverse of this 1k, we get 0.001. So 0.001, this will be the time, seconds. Now we want a delay of 5 seconds, means how many clock cycles will elapse? 5 into, so it will be simply like 1 into 5, 5k. So this many number of clock cycles will elapse. So simple thing, what we will have to do is, if we want to generate a delay of 5 seconds, then we will have to load the auto reload value as 5k. Now same theory, starting from 0, that's why 4999. The count value is 000, it will be up counting, and thus it will start. Now we are not interested in timer capture, compare capture register. Again this CCMR2, CCMR3 compare capture registers, not DMA or DMA registers, we are not interested, and option registers, we are not interested. So see, what we have done is, we have used the internal clock, we have set up counting mode, then we have set the prescaler of 8000 to get 1 kilohertz clock, timer clock. Then we have set the auto reload value of 5000 to get a 5 second delay. Then initial value we have set it to 0. Then we have enabled the timer. Now once we have enabled the timer, what we are doing is we are checking the if the update flag is set or not. So we'll compile the code. We get 12 errors. Why we get 12 errors? Because we have not included the timer.h file. Once we include this file, our errors will be resolved. So this way we can configure our timer Now in next video we will see the actual application, the actual delay that has been generated, that we'll see in the next video. So I'll once again repeat all the things that we have seen. We have declared the structure, timer register structure, then we have declared the timer 2 base address, then we have declared the status register bits that we are interested in, UIF and CR register, CR1 register bits that we have done. Then in main the RCC APB1 ENR, in which the timer peripheral clock enable bit is there, so that we have declared. We have declared this bit number macros in order to simplify our code. Same RCC APB1 ENR. So this is one way, or you can do like this, like you can specify the bits position and this into the timer register or the RCC registers, RCC file, and then you can use it. Then we have taken one pointer of timer register definition structure and we have given the base address of this. So this way this pointer will start pointing from this position or this address. Then we have declared the prescaler. So by default, like we are using the default setting, that's why we are using internal clock and up counting mode. These are by default set, these are reset values. Okay, so that's why we have not set it very specifically or manually. If over here, if you want to have down counting, then we'll have to set the down counting mode to timer 1 CR register. Now after that we have declared the prescaler, assuming that we have 8 megahertz of internal clock. Then we have set the ARR value, auto reload value. Then we have set the counter. Then we have set we have enabled the timer. After enabling the timer, what we are doing is we are waiting for timer update event. Once the timer update event has occurred, we are clearing the flag, and once the flag is cleared, we know that the timer event has occurred, we have cleared the flag for next event to occur, then we are toggling the LED. So this toggling part we have seen in previous tutorial, so that's why I'm not explaining it over here again. So this way we have generated a 5-second delay. We will see the actual output of this in the next video. So we will see the code output on actual hardware. That's why it will be in the next video. So if you enjoy the explanation, if you enjoy this video, please give it a like, share with your friends, and thanks for watching. अगर आप लोगों को ये वीडियो अच्छा लगा है तो आप आपके दोस्तों के साथ शेयर कीजिए, ये वीडियो को लाइक करिए, एंड अगले वीडियो में फिर से मिलते हैं. थैंक्स फॉर वॉचिंग दिस वीडियो. हैव अ नाइस डे.